It says, identify what is being oxidized and what is being reduced, if anything, in the following reactions. Also identify the oxidizing agent and the reducing agent if it is a redox reaction. So if you haven't watched the previous question, please do that first. So here we have Na plus O2 yields Na2O. So in this case, we have a main group metal. So for main group metals, the oxidation state is equal to the charge. So the oxidation state of elements is always 0. So the sodium is 0 here. The oxygen is 0 here. If we have sodium in a compound, sodium is a 1A metal, so it's plus 1. Oxygen is a 6A nonmetal, so it's minus 2. Oxygen is always minus 2, whether it's covalent or ionic compounds. Sodium's not going to be in a covalent compound, right? Not in Gen Chem. So let's take a look at this. So we have sodium going from 0 to plus 1, and we have oxygen going from 0 to minus 2. Remember the mnemonic device, Leo the lion says grr. And what this means is losing electrons is called oxidation, gaining electrons is called reduction. So if sodium went from 0 to plus 1, did it gain electrons or did it lose electrons? Well, electrons are negatively charged. So if it went from 0 to plus 1, it actually lost an electron. So sodium underwent oxidation. Oxygen went from 0 to minus 2. It gained 2 electrons, so it underwent reduction. Okay, this is how it works. So if something undergoes oxidation, it is the reducing agent. If something undergoes reduction, it is the oxidizing agent. And the reason for this is the thing that undergoes oxidation reduces the other thing, the thing that undergoes reduction. The thing that undergoes reduction oxidizes the other thing, which is oxidation. In Gen Chem, oxygen is usually the oxidizing agent. That's where oxidizing agent got its name from. There are things that are strong enough to oxidize oxygen, but you're not going to see any of those here. All right, let's look at zinc and copper sulfates. The first thing I notice is that sulfate stayed as sulfate on this side and stayed on sulfate on this side, which in oxidation reduction reactions essentially means I can ignore it. Because if it stays as a sulfur bonded to 4 oxygens with a 2- charge, the oxidation state on sulfur and oxygen have stayed the same because it hasn't changed. But zinc and copper have. Zinc went from an element to a compound, and copper went from a compound to an element. So the oxidation state of zinc solid is 0 because it's an element. And the oxidation state of here of copper is 2 plus. Why? Because sulfate is 2 minus. So since sulfate is 2 minus, copper must be 2 plus. So this is plus 2, or 2 plus. In this case, zinc is the same thing. Zinc is 2 plus because sulfate is 2 minus. So here this is plus 2. And copper here is 0 because it's now an element. So we went from 0 to 2 plus and 2 plus to 0. In this case, 0 to 2 plus is losing electrons. So this is oxidation. Said another way, zinc is the reducing agent. Copper went from plus 2 to 0. That is gaining electrons. It has a positive charge, now it has no charge. That's gaining electrons. So this is reduction, or said another way in this case, copper is the oxidizing agent. All right, let's look at the last one. The last one, we have magnesium 2 plus with nitrate going from sodium plus and carbonate to magnesium carbonate and sodium nitrate, and we get a solid here. First thing again that I notice is nitrates have not changed, carbonates have not changed. So there's no oxidation or reduction going on in our polyatomic ions. Let's look at magnesium. Magnesium's in a compound here, so it's plus 2. It's in a compound here, it's a 2A metal, so it's plus 2. Sodium is, in this case, plus 1 because it's in a compound. All right, sodium's always plus 1 in compounds. And sodium over here is also plus 1 because it's in a compound. So this went from plus 2 to plus 2 and plus 1 to plus 1. There is no change. This is not a redox reaction. So there is no oxidation reduction occurring in this double displacement reaction. And in fact, double displacement reactions are not oxidation reduction reactions. In this case, you have a single replacement reaction, displacement reaction. Those almost always are oxidation reduction reactions. And then here you have a combination reaction. And if you have elements forming compounds, those are going to be oxidation reactions as well, because in elements the oxidation states are 0, and in compounds they are not. So sometimes you don't have an oxidation reduction reaction occurring at all.